Good morning friends. Welcome to Parnika Tutorials YouTube channel. In this video, I want to discuss one of the gate question which came in the year 2005. First let me read the question, then I will discuss the solution with you. The grammar A determines AA, open braces A, closed braces or epsilon. I hope it is looking as an epsilon only. Is not suitable for predictive parsing. What is predictive parsing? LL1 parser. Am I right or wrong? Okay. Because the grammar is, they have given option as ambiguous, left recursive, both A and B and none of the above. Now predictive parsing will come in what category? Top-down parser. Am I right or wrong? So those who have watched my video related to predictive parsing, they can easily solve this question. So I request you to pause the video. If you know the solution, pause the video and try to find the solution, and whatever the solution you are thinking is right, please write that answer in the comment section, and then you check the solution with me and verify whether your solution is right or wrong. If you have done mistake, then please learn the concept again, because these are the gate questions. If you are writing for gate exam or any competitive exam, or you are preparing for university exam, you should be very sound at the basics. Okay, so now let me discuss what is ambiguous grammar. A grammar will be called as an ambiguous grammar if it has more than one leftmost derivation, or more than one rightmost derivation, or more than one parse tree. Am I right or wrong? As we already discussed that ambiguous grammars will not be allowed by most of the parsers except the one of the bottom-up parser, which is operator precedence parser. So LL1 parser will not allow the ambiguous grammar. Now we will check whether it is ambiguous or not. What is left recursive grammar? First we need to check whether it is recursive or not. Then only it will come whether it is left recursive or right recursive. Now if you see that A is calling itself, a function is calling itself, we will call it as a recursive function. Now if you say that A determines A is determining itself, so I can say that it is a recursive. Now what is left recursive? If A is determining A and the A is there in the leftmost side of the right hand side production, then we will call it as a leftmost recursion or left recursion. If it is there in the right hand side, then I will call it as right recursive. Now if you look at this, is both left recursive and right recursive, and then they are saying both A and B and none of the above. Even I said that the top down parsers will not allow the left recursive grammars. Am I right or wrong? So we will check. Obviously I can say that B is correct, because this is a left recursive grammar and top down parsers will not allow the left recursive grammar. So that's why we have discussed how to convert the left recursive grammar to its equivalent right recursive grammar. Am I right or wrong? Now we will check whether it is ambiguous or not. If it is not ambiguous, then answer will be B. If it is ambiguous, then I can say that both A and B. Now we will check whether it is ambiguous or not. How to check whether it is ambiguous or not? I will take a one string which can be generated over this grammar. Okay. Now this string I have taken, what are the parse trees I can generate? Now from A, why I am starting from A? Because for this grammar the start symbol is A. So A can be determined A and A. Okay, this A can determine open braces A, and this A can determine epsilon, and this one can determine epsilon. Now if you yield the parse tree, what you will get from the start symbol, whenever you get a terminal, you write it. You got a epsilon, write it. You got a terminal, write it. And then again you got the epsilon and you got the start symbol. So this is what we will call it as yielding of the parse tree. Epsilon is what? The length of the string is 0. So if you consider epsilon or not, it is not a problem. And one more thing I told in the theory of computation course, any alphabet concatenated with epsilon, you will get the alphabet only. So this is the string, this parse tree is generated. Okay, no problem. Let me see any other parse tree is possible or not. From the start symbol A, I am determining A and A. Am I right or wrong? And this one I will give the epsilon, and this one I will give a on a, and this one I will give the epsilon. So this is the another parse tree you got. If you yield it, you will get the same thing. Now you can tell me, sir, I can also get another parse tree. What is that one? Is that, sir, I will take a. Let me erase this one so that I can use this space. Sir, instead of going like this, even I got another parse tree. A, directly I will write A determine A, and this is epsilon. So if you look at this one, for the string, for the given grammar, you got more than one parse tree, then I can say that it is ambiguous grammar. Am I right or wrong? So ambiguous grammar will not be parsed using predictive parser, and it is already, we discussed that it is a left recursive grammar. Left recursive grammar also not allowed by the top-down parsers, which is a recursive descent parser and a predictive parser. So predictive parser also does not allow the left recursive grammar. So this grammar is not allowed by the predictive parser because it is ambiguous and left recursive. The right answer for this one is C. Is it clear? I hope you have understood how I solve this question. If you still have any doubts related to this concept or related to this question, feel free to ask me in the comment section. I will try to clear your doubts as soon as possible. Thank you for watching my video. Have a nice day.